Hi, today we will learn how to multiply two complex number. We already discussed that how we can represent a complex number in polar form, but sometimes it is asked that we have two complex number and we want to multiply them and then get their polar form. So how we can get polar form of two numbers, complex number which are being multiplied. So let's suppose we have two numbers like -2 plus 2 iota and 1 minus iota. So these are two complex numbers and we want to multiply them and then get their resultant polar form. So we suppose let first number is z1 and it is equal to -2 plus 2 iota, and the second number is z2 is equal to 1 minus iota. So for this we will have a magnitude like r1, and in magnitude we take the square root of the two numbers with squares. So we will have this one, and this is equal to r1 under root 4 plus 4, and this would be equal to r1 equal to 2 under root 2. Whereas for second number we will have r2 is equal to under root 1 square plus, here is also -1, so -1 square. So we will get r2 is equal to under root 2 . Now as we know that we have argument as tan theta is equal to x divided with y. So argument for first number would be 2 divided with 2, and we will get theta inverse theta 1 tan inverse 1. So this would come out pi by 4. Now the second for the argument of the second complex number is tan theta 2 is equal to, this is 1 and here is also 1. So we are not considering for the time being here positive or negative sign. We are just taking numbers. So this one is equal to 1 divided with 1. So theta 2 is equal to tan inverse 1. So this would also come out to be pi by 4. But here if we see, we have in case of first complex number, if we see here x is negative and y is positive, and we know that in the first quadrant we have argument for any complex number as arc theta, and in the second quadrant we have argument pi minus theta, and in the third quadrant we have argument minus pi plus theta, and in the fourth quadrant we have argument minus theta. So in this case, if we consider first quadrant complex number, then here we will be having that x is -1 and -2 and y is +2. So it means x is negative and y is positive. So in this case, x negative and y positive, it means our complex number would be in the second quadrant. So in second quadrant we have argument as pi minus theta. So its argument would become out argument for z1 would be equal to pi minus theta, and we have pi minus theta 1 value is pi by 4. So we are left with argument z1 is equal to 3 pi by 4. Similarly, for second complex number we have argument z2, and if we see, we have x positive and y negative. So x positive and y negative, it means that our complex number is lying in the fourth quadrant. So in the fourth quadrant we have the value as minus theta 2, as in the fourth quadrant argument is minus theta. So here for the second complex number we have theta 2, so that's why we have taken this minus theta 2. So this would become minus pi by 4, argument z2. Now we multiply r1 and r2. r1 we have 2 under root 2 and r2 is under root 2. So we are left with the 4, r1 and r2. Now combined argument of both numbers is argument, because we are multiplying both numbers, so argument of z1 z2 would come out theta 1 plus theta 2, as we already have discussed that when we are multiplying two complex number we only add their argument. So we are left with argument z1 plus argument z2. So we have argument z1 z2 is equal to is equal to 3 pi by 4 minus pi by 4. So we have 2 pi by 4 and this would become pi by 2. So we know that when two numbers are being multiplied, we multiply their magnitudes and their arguments are added, so we have cos theta 1 plus theta 2 plus iota sine theta 1 plus theta 2. So this would become as r1 r2 is equal to 4 and cos theta 1 plus theta 2 is pi by 2. Sorry, pi by 2 plus iota sine pi by 2. So we have 4 is pi by 2. So this is the polar form of a complex of two complex number when they are being multiplied. So hence the answer.